So the first thing we can imagine is that we're going to put a bit at the front of every allocated block, or every block, to say whether it's allocated or not. And we start out with some chunk of memory where it's all unallocated, and after a malloc, then we set a bit in this first word here to mean that these following four words belong to the program and they're allocated right now. And then when P2 is freed later, we can set that bit from 1 to 0 to say, now this is a free block. Note that the block header here, the bit is going to sit in something we call the block header. That is not part of the payload of the block. So when the application calls malloc and gets a value back for P1, it's going to point after the header. That's the payload pointer that we return from malloc. But every block from the allocator's perspective is going to have one extra word which corresponds to the block header. So where there's a malloc 6 here, we actually have to use 7 words of memory to implement it. Also, this bit, we have a lot of space in this word, and it turns out a bit is not enough information because when you want to reuse this free block, say, for malloc 2, we see that the initial block is allocated, but how long does it run? We're going to need to keep a count of the blocks, of the words in a block. And so we'll put that in the block header as well. Our block header has 2 pieces of information. It has how big is this block, and is it allocated or not. So after we allocate 4 words for this for request, we get a block of size 5. We're going to put in the block header a number that corresponds to the total size of the block, not just the payload. That'll be convenient, more convenient for all sorts of reasons. So again, keep in mind that this size is the size of the whole block. The payload starts right after that. And then we have the 1 bit there to say that this is an allocated block versus this 15, which is unallocated. When P2 is freed, then that 1 bit has gone to 0. And then when we want to allocate P4, then we can search through this list, search through the set of blocks to find one that's currently unallocated and is big enough. In fact, these numbers effectively form a linked list of blocks because we can start at the first block, follow it of size 5 words to get to the next block, whose header says it's 3 words, and the next one is 3 words, and the next one is 7, and so on. So to refine our answers to some of our design questions, how does free know the allocated block size? It's because it's going to be starred at the start of the block. And while free will be given a payload pointer here, it can just back up by 1 word to get to the block header. And unallocated space, that's represented by setting a bit in the block header to 0 instead of 1. How do we find space to satisfy a request? Well, for now we're just going to walk through the linked list of blocks and find the first one that's available and big enough. How well are we going to keep track of memory? Well, we have some overheads related to the block and related to alignment, but we can split blocks like this to keep track of unallocated space that still exists between some allocated space. And finally, we're going to get more pages from the kernel whenever we need more space in our linked list. Whenever we search through the whole list and we didn't find a block that was big enough. Not in this case, but if we do a malloc 3 next, then that needs a block size of 4, so we would have to make more memory at the end. For that matter, how do you know when you're at the end? Because in this picture, we walk 5, 3, 3, 7, 2, and then how do you know that this is the end of the list? There's a couple of possibilities. One is that you keep track of a current end pointer, like the break pointer, or just use the break pointer to tell you when you've gotten to the end. Another way, and one that turns out to be more general, so we're going to use it, is that you add a 0 size block to terminate the chain. So this 0 is, well, it doesn't make sense because the block is actually of size 1 if you think of it that way, but 0 is a special value that means it's the terminator for the linked list. So that's what we're going to do.